So this is a question, and even though in geometry we're not talking about area yet, this is something that you have learned in the past, and you should be pretty, I don't want to say experts, but you should be pretty familiar with finding the area of rectangles. We're focused on this diagram right here, not the one on the right. So that's just something to keep in mind, and that's kind of the first decision point you have to come to, like, where am I looking? So Mr. Smith wants to build a 3-foot wide walkway. So you can see that this 24 right here is referring to this width right here of the house itself. And this 30 is for the length of the house. So if we get the area of the house, just the house itself, that's going to be the length times the width. And that's going to be 30 times 24, which gives me, when I multiply that out, I'm just going to do it real quick. That's 720. And I know that's square feet. So that is the first part of this problem. And hopefully you guys are familiar enough with that area, and that part of it makes sense, even if you didn't do it quite that way yourself. But now we have this larger rectangle. This represents not only the house, but the footprint of the house and the walkway. And this is given by 36 by 30. So I'm going to have a different, I'm going to call this, the subscript right here, this refers to the house, and this one refers to the walkway with the house. So maybe W isn't the best word, but anyways, it's still length times width, which is going to be, in this case, 36 times 30. And that means when I multiply this out, I get 1,080 square feet. So if we're trying to find the area of the shaded region up here, which is going to be, well, what that will end up being is our big rectangle minus the smaller one. I can just kind of subtract that away, and what's left over is just the shaded area. Oops. So there we go. All right, so I can take the 1,080 minus the 720, and that gets me a total of 360 square feet. And the units come from the fact I was subtracting 1,080 square feet, oops, from and 720 square feet. So the units were already there. There you go. That's our answer. It is C. So good job, everyone who got that. If you didn't get it, hopefully you caught where you made your mistake, and hopefully this is ringing a bell. You're like, oh yeah, I remember doing stuff like this. We'll be looking at parallel lines and transversals and transversal angle rules today. But first we have a little bit of other stuff to talk about. So with parallel lines, we are, well, you know what parallel lines are. I just want someone to, somewhere in the middle of the screen, just draw some parallel lines for me. All right, and we can have two sets. There we go. That is perfectly fine. And here's what I want to do. This is a term that you might or might not remember. I bet you've heard it before. And it doesn't have to be the same people who drew those parallel lines. Well, sorry, before we do the next part, let me talk a little bit about parallel lines. So a lot of times you'll actually see arrows at the end. So I could do this. And frequently there will be an arrow in the middle. And what the arrow is notation for is it's showing that those two lines are parallel to each other. And so maybe you can see something like this where there's two arrows, which show that those are also parallel, but it's a different parallel than this one is. So that notation, just be prepared. If you see those lines, that's what that's referring to. Okay, so with these parallel lines, and it can be a different person who draws this on. If you remember what a transversal is, can you go ahead and draw a transversal on that diagram? And I'll just wait about 15 seconds. If no one draws one by then, I'll assume you guys have forgotten. There it is. There it is. Okay, I was just about to do it and you came through right at the buzzer. Okay, so we got parallel lines right here. A transversal is just, well, I'll bring this up. A transversal is a line that cuts through two, it could be two or more parallel lines. So if we had another parallel line right here, that could cut through that one also. But typically we're looking at two parallel lines with a line cutting through it. This is your transversal. And it's important to know that term because it's going to be important for our angle rules to know what the transversal is, because we're going to be talking about which side of the transversal an angle is. So if you can understand that starting now, that's a good thing. We're going to look at transversals a little bit more before we move ahead. All right, so let's look at this. I want you to draw a line on any street that you think is a transversal. Okay, we got someone drew a transversal along Blue Island Avenue. And this is in Chicago, by the way. There you go. I got another one there. Okay, so you're drawing the parallel lines for it. Very good. So we got some parallel lines. And of course, we can see there's a lot of parallel lines here. So I didn't quite get that on the street. Even this one almost qualifies. So there's a lot of streets right here that are parallel, and this Blue Island Avenue is cutting through all of them. And now some of you might be thinking that there's a lot of transversals in this diagram, and you're absolutely right, there are. So another transversal is this one right here, because there's no rule that says what angle it cuts through at. This Blue Island Avenue cuts through at kind of at an angle, not a right angle, we can say. But what is that? Loomis Street cuts through all these at kind of a right angle, and that's still a transversal. If I clear all this real quick, I can show you another transversal. And again, we could look at transversals all day long, but I've got all these parallel streets right here, and 18th Street is a transversal for those. So if this is helping you to understand the idea, again, you need to know what a transversal is, and it's typically not super complicated because this is the diagram you're going to work with a lot of the time. All right, so in this diagram, I want you guys, and it can be a lot of people, I want you to draw an arc on every angle you see in this diagram. So I was kind of counting as you guys were drawing that. How many angles are there in this diagram?
8.
8, yeah. And I think it's just important to realize that there are 8 angles there, because sometimes we can just get kind of tunnel vision on one particular part and not realize there's a lot of angles here. But it's also limited. This, at first, you could be like, oh my gosh, there's so many angles. And you're like, oh, it's just 8. So, I think it's helpful to kind of number these ahead of time. Now, there could be even more angles. If I had a different transversal cutting across, then I've got 8 more angles here and here. And then we could get even real complicated and do something like this, or I got these 8 angles, and then we've got 4 more in the middle. And we could get even more technical than that and talk about other angles. But bottom line, there are 8 main angles in a typical diagram that looks like that. Okay, so let's look at this a little bit more. So in a diagram like this, there are going to be some rules. There are going to be names for angles, and these are all going to be names that you have heard before in 8th grade or around that time. But a lot of you will have forgotten, so it'll be reminders. So these sets of rules that we're going to learn, we can call them parallel angle rules or transversal. It's not an official name, but just if I'm talking about your parallel angle rules, well, we're talking about parallel lines, and then all the angles associated with parallel lines and a transversal cutting through. So just keep that in mind. That's what we're talking about today. We're going to practice with it tomorrow. The first unofficial rule, this is not a named one, but the first rule I want you guys to keep in mind is this: if 2 angles appear to be congruent, they are. So I could pick any 2 angles here. And if I saw this angle right here and this angle right here, and I say to myself, those angles, they look both of them pretty big. This one's definitely greater than 90 degrees. And this one's greater than 90 degrees. So of course we call those obtuse angles. So those two obtuse angles, you know, what are they? I don't know, but I can say they are congruent. So I mention that now because there are going to be times where you know, or you forgot what to call a rule. You forgot what to call two particular angles. And I say, what would you call these two angles? And you might forget what those are called. And we're going to learn those in a minute. But if I ask you, what are those two called? You might forget, but you can at the very least say, I don't know what they're called, but I do know these are congruent because that's an acute angle, that's an acute angle, and therefore they have to be congruent. So if that's a takeaway that you have, that's a good starting point. That's a good place to kind of as a foundation. All right, now we've got the angles numbered, and I want you guys to draw arcs on every angle that's congruent to angle 1. So there we go. You can see that out of the 8 angles that are in this diagram, 4 of them are congruent to each other. All right, and so the next part will probably be pretty straightforward. Find all the angles that are congruent to angle 2. And I'm going to put 2 arcs for this one, so you guys can put 2 arcs as you label the rest. There we go. 3 is, 7 is, and what else? There it is, 6. So you guys did a good job. I'm going to redraw these arcs just to make it look a little clearer. So I have all of these I'll mark in red are congruent to each other. And then these guys I'll mark in blue are congruent to each other. So this is just good stuff to keep in mind. And maybe something, this will come up in a minute, so maybe I could just throw it out here right now. Notice if I took this angle and I translated it down, and we learned about translations already, but if I translated that down, this would map perfectly onto this angle right here. It would look exactly the same. So that's kind of an important thing to keep in mind also. So just visually as we're looking at it, hopefully you're keeping these ideas in mind. All right, I'm going to move ahead now, and we're going to talk about the actual rules that we have. And you can see it's the same diagram more or less for each one of these, but we have different angles highlighted. So we've got, in the first example here, we've got what are called corresponding angles. And I'll explain why we call them corresponding angles. So, I mean, here's an example of corresponding angles right there, but those are not the only corresponding angles that we have in this diagram. So notice that this angle right here is on the bottom right of its intersection. And this angle down here is on the bottom right of its intersection. So their positions correspond to each other. But maybe a better way of thinking about it is like this. Just like we talked about with the translations, if I took that entire angle and translated it down, if I did that, then this angle would map directly onto this angle. So that's kind of what we mean when we say they correspond. That if I translated one angle onto the other, they would be in exactly the same spot. All right, and that's different from, if you look at this example, if I translated this one down right here, the corresponding angle is right there. So we're not looking at corresponding angles in the next example. And I'm not going to talk more about the example right now. So let's just focus on this one. Corresponding angles, we can see that these are both obtuse. And so just right away with that initial rule I told you to keep in mind, we should tell ourselves these two angles are congruent. You might forget they're called corresponding, but you can remember that they are congruent. So if I call this angle A and this one angle B, then the measure of angle A is going to equal the measure of angle B. And that's the main takeaway. Now we're going to do some practice problems with this where we actually plug in some numbers. But for right now, if you can just remember they're congruent, you're good to go. So I will maybe write that in right here, congruent. The next one, I'll call this angle A, and this one angle B. And the name, what I'll probably do is give you the name for this and then explain why we call it what we call it. So we call this same side interior angles. All right, so the same side part of this is referring to the transversal. All right, so if I've got angle A is on the left side of the transversal, angle B is on the left side of the transversal. They're both on the left, therefore they are same side. So that's where that comes from. All right, now the interior, if we look at our parallel lines, I'm going to come down to this example. The inside of this is called the interior. And then outside of it in either direction is the exterior. So if my angles are inside the parallel lines, I would call them interior angles. So these are same side because they're both on the left side of my transversal, and they are interior because they're inside the parallel lines. All right, so I will get rid of that real quick. So same side interior angles. If I focus on the angles now, I can see that this one right here is acute. It's less than 90 degrees. And then if I look at this one right here, that one is greater than 90 degrees. These are definitely not the same angle. So if they're not the same angle, then the trick is they are supplementary. And luckily we already learned that with our linear pairs. So what that means is that these have to add up to 180. So the measure of angle A plus the measure of angle B have to add up to 180 degrees. So I will put that down right here. Now, just like we have same side interior angles, we also have exterior angles. So right here, if I call this angle C and this one angle D, then they're both on the right side of the transversal. We can see that. But now they're both outside of the parallel line, so they are exterior. So I would call these same side exterior. And we have short names for these, abbreviations, if you will, they're acronyms. So I would call this SSI. That makes my life a lot easier if I refer to same side interior as SSI. And it makes my life a lot easier if I refer to these guys as same side exterior or SSE. And I know that the rule doesn't change for exterior angles. The measure of angle C plus the measure of angle D equals 180 degrees. Okay, are there questions on this before we move ahead? All right. So the corresponding angles, just to come back to this real quick. If we're talking about this area inside as the interior, notice that angle A is in the interior, but B is in the exterior. So we can't call them interior or exterior angles because it's a mix and match, right? So just to keep that straight, corresponding has one interior, one exterior angle. Okay, so let's just look at the last one. This is something you, again, will hopefully remember. These are alternate interior angles. And the good thing I want to emphasize right here is that these names explain where you'll find the angles. Corresponding is not quite as clear as the other two, but when you see alternate, this means that this angle is on the right of the transversal. This angle is on the left of the transversal. So that means they're not on the same side, and they alternate. So that's clear enough. And they're both inside the parallel lines. So that is going to be your interior. So now if I label this A and B, if I just focus on the angles themselves, they're both obtuse. And going back to our original kind of rule of thumb, if you want to think of it that way, is that if they appear to be the same angle, they are. So these are both obtuse. So that's going to tell me that the measure of angle A is equal to the measure of angle B. And these are congruent. All right, and just like we had with our same side exterior angles, we have an exterior version of these. So if I call this one C and this one D, I could also have alternate exterior angles. So the measure of angle C will equal the measure of angle D. And like you might guess, we've got names for this. Alternate exterior angles can be referred to as AEA. Alternate interior can be referred to as AIA. Okay. If you find this screen helpful, I would encourage you to take a screenshot of it right now. And I'll leave this up for about 10 seconds or so for everyone who wants to have a screenshot of this to get it. All right. Does anyone need more time? I think in case you want the screenshot, but you're not sure how to do it, it's your power plus your home button at the same time, unless that's changed, but that's how it always has been. All right. So there you go. I just took one to make sure that worked. All right, I'm going to move ahead and let me clear all this. So at this point, raise your hand. Let me know you're here. All right, so the homework for tonight, there's actually a part of it I didn't include here, but you're gonna have some practice with these rules, as you might imagine, and there's other practices as well. So at this point, I'm actually going to move us over to, I think the first thing I'm going to do is just show you this. I did post an angle rules reference sheet. Sorry, I just want to make sure that's available for you guys to see. Anyways, we've got the angle rules reference sheet, and today's class right here, we've got two things you need to do. One of them is just radicals practice. So I'm actually going to start with that one, then I'll come back to the transversal angle rules. So this is just going to be your practice for this week, and it's going to be more the same, but it's in Delta Math. So make sure that you are coming over here, practicing with this, trying to find the simplest form of this radical. All right, I think there are 10 problems as part of it, and that's basically all there is to it. If you have questions on any of this, you can let me know. All right. All right. There we go. So with the other part, this homework that relates to our topic of the day, we've got, and I'm not going to go through any of these problems, but I just wanted to explain what's on your homework. And I can go over this assignment again at the end if you guys have questions, but I'm going to run through some of these problems. All right, and notice there are 6 problems over here on the left that all deal, you can see the parallel lines and the transversal cutting through. There are 6 problems over here. You need to do all of them. On the right side, this is review of last week. And you can see that as part of your assignment, every problem on the left side you need to do 1 through 6, and the evens only on the right side. So you only need to do 2, 4, 6, and 8. So there you go, 2, 4, 6, and 8 right there. You can see we're using things like vertical angles and angles at a point for those problems. I did upload the one that has the answer key on it. I don't mind that. It only has the answer key for these problems, I believe. So if you want to double check your work, I highly encourage you actually do all the work first, and then you can double check your answers, make sure you did it right. So that is the homework. Now I will share something different. I have a different worksheet that I will run through a few problems, and that's what we're going to spend the rest of class doing. If you have any questions about anything, we can go through more than what we're going to do as a class. But let's start just by naming some angle relationships. Remember, the faster you guys respond, the less time we have to sit in class. But let's just start with number 3. What would you call that? Would you call it, well, anyways, what would you call it? So I gave you your 4 options up there at the top.
Do we like write this in the chat or do?
You can write it in the chat. You can write it on the screen. You could circle one of the choices. You could say it out loud. Well, yeah, thanks for asking that. Any way you want to convey that, you can.
Okay, corresponding, right?
Corresponding, yes. And we can see, again, the idea with corresponding is if I translated this entire angle down and had it land right on top of the other one, the X and the Y would be in exactly the same place. So they correspond. So that's the idea right there. I'll go ahead and write that in. Corresponding angles. What about number 4?
Is that consecutive interior?
Yes. Now we call it same side interior, but on this worksheet, that's why I crossed out the consecutive interior and replaced it with SSI, same side. So maybe I'll just do this. But you're right. Same side interior. The same side comes from the facts, and sometimes it helps to draw the arc for the angles, and that helps give us a little better visual on it. So they're both on the right side, that same side of the transversal, and they're on the inside of those parallel lines, so they are interior. You've got it. So, all right, we'll do 5. What do we got there?
Alternate interior.
Okay, everyone agree? Thumbs up if you think that's right. Got a thumbs up there. Okay, getting a few thumbs up. There you go. That just lets me know that everyone's looking at it and thinking about it. Okay, very good. So if we look at these 2 angles, again, I'm going to draw. I know you don't have this. I mean, you could kind of draw on the screen here. Anyways, if you look at this, X is on the left side, Y is on the right. So they're not same side. That means they're alternating, alternate, and they're inside the parallel line. So alternate interior angles. And this is where it's helpful just to write the acronym. I know what that means. You know what that means. So don't bother writing the whole thing out. Last one, what have we got here? Let's see if
alternate exterior angles.
Good job, good job. Alternate exterior, same thing. They're on the left and the right. So they're alternate. The interior is here and they're outside of that. So we've got alternate exterior angles. All right, very good. So with these problems, it's just identifying. All right, with the next problems, you've got, I'll just pick, we'll just start at 11. Why not? So now we've got some numbers thrown in here. And the first thing that we can do is, after we put arcs for our angles, but the first thing that we can do is we can actually come up with what this angle relationship is. And what would you call this?
Alternate exterior angles.
There you go. It's almost the same diagram we just had. So it's alternate exterior angles. And you can do this one of two ways. You could memorize that rule that says that alternate exterior angles are congruent, or you could just look at this and you could say, well, I know I'm dealing with a transversal and parallel lines. These are both obtuse, greater than 90 degrees, greater than 90 degrees. So therefore, these are going to be congruent. So my question mark is just 110 degrees. And I'm setting them equal to each other. So technically what I could do is I could write the measure of angle question mark is equal to 110 because they're equal. That's all there is to it. All right, let's jump down to 13. So what would you call our angle relationship in 13?
Same side.
Same side. The interior or exterior?
Interior.
You got it. So now we've got same side interior angles. When you take your test, you're going to have a reference sheet available to you. So you will not have to have this memorized. But if you look at your reference, you'll kind of determine, are these congruent or are they supplementary? And can anyone remember, what do you think these are, congruent or supplementary? So are they equal or do they add up to 180?
Add up to 180.
Add up to 180. Pretty straightforward. Once you know that, it's pretty straightforward. So this is an obtuse angle right here. This one's acute, so they're not congruent. They are not congruent, which means the only other option for this is that they are supplementary. So the measure of angle question mark plus 100 degrees they have to add up to 180 degrees. And now when I subtract right here, I get that the measure of angle question mark is 80 degrees. So we set up an equation and now we can solve it. Now, if they're congruent, you don't even have to set up an equation for problems like this. You just say this angle equals this one and we're done. But here we had to do a little bit of math. Okay, any questions on this before we move to the last part? Or what you can do is you can kind of make notes to yourself if you want to come back to some of these problems. So now we can see these problems look a little more complicated and we'll figure out if they really are or not. So let's look at, I don't know which one looks complicated. Let's look at 23. All right, so 23, maybe the first thing is identify the angle relationship. We've seen this one quite a bit. Hopefully a lot of you can say it by now. What would you call this?
Alternate exterior angles.
All right, you're becoming our alternate exterior angle guru. All right, and hopefully a lot of you at home are following along with that as well. So knowing that this and this are alternate exterior angles, we know that these two angles are congruent. In fact, we can look and we can see they're both obtuse. They look like they're the same angle, and therefore they are. So nothing really tricky with these types of problems. So I'm just going to set them equal to each other. -1 plus 14x equals 12x plus 17. And just to make sure that's really clear, this angle is equal to this angle. And that's where the equation comes from. I know that they're congruent, so I just called it good. Let me get rid of this. All right, I'll rewrite the AEA. And in parentheses here, I'm just going to put they're congruent. And I can also remember this is, I don't know that actually we've introduced that. This is a symbol that we use for congruence right here. But anyways, let's just move ahead with the problem. We'll keep seeing that symbol. So now it's just an equation to solve. I'm going to start by combining my numbers. I'm going to add 1 to both sides. So 14x equals 12x plus 18. And then I can subtract, I want to get my variables together. So subtract 12x from both sides. Those cancel out. I get 2x equals 18. This is just basic algebra stuff, so you should be able to follow along with this part of it. Divide by 2, and x equals 9. That's it. We have found x, and we had to know that they were alternate exterior and they were congruent before we could do that. Because it's easy to set up your equation the wrong way. So make sure you're practicing with that tonight. We will get more practice with only these rules and the previous ones tomorrow. So we're not going to jump and throw in any new content tomorrow. Tomorrow's just another practice day to really master this idea. And then Wednesday, we'll throw in the last bit. Okay, so if you want to see some more, if you have questions about the assignment for tonight, anything that you need questions with, please stick around. But otherwise, that is all we're doing today. You can go and work on this, and I will see you tomorrow.